While we're on the topic of like futuristic stuff, I was watching a video on bionic eyes. Have you looked into that much?
So I think that technology is a ways away. The closest we are right now is in some blind subjects. They're implanting a chip behind the retina. Light stimulates it, and then the chip is connected through electrodes near the visual cortex in the back of the brain,
Right.
and it gives them a semblance of motion or image, but it's not true image. So that
It's a
technology,
pixelated image from what I've seen. Like,
right? Yeah. So if you imagine if you were totally blind, the world is black, and you give somebody at least a sense of motion, or you walk in a room and you can see something go across the room. Well, that's a heck of a lot more than just totally black.
sure.
There's really no detail involved in it. But if you give somebody a sense of movement, or just place and space as far as the visual world, without detail, is a big advancement over total blindness.
Sure. Yeah,
Uh,
the videos that I've seen, they they show you like the image that potentially these people would be, um, their brains will be able to generate, and it's like a pixelated image. So like, I won't be seeing you necessarily, but I'll be seeing
a
like
representation.
some kind of just pixels,
Yeah,
and I'll know that there's a person in front of
exactly.
me.
That's what I'm talking about. The
Yeah.
problem is that every cell in the retina in the eye is represented in the visual cortex by a system of cells. So every cell, it's like the pixels on a high def TV.
Hmm.
If you imagine a TV, all the pixels, uh, each pixel on a TV is represented by a place on the chip, the computer chip in the TV. But let's say you move a pixel from the center to the outside and don't tell the semiconductor, well, that image is going to be misrepresented.
Hmm.
So it really comes down to how do you map the locations of where the photoreceptors were to the areas of the brain. And if they could nail that down to perfection, have each area located about 1.5 million pixels in the retina, if you're going to use the pixel analogy, if you could get all that mapped out, you could get a better true representation of what an image is. And so that's kind of the things that the sciences are working on.
Yeah.
But it's kind of like marrying the medical with the electronics field, you know,
Hmm.
semiconductor field.
That's fascinating.
Yeah.
Now, is the challenge, so for people who would be candidates for this type of technology, do they have an issue with the retina or with the optic nerve?
Both. It could be both.
Okay.
Yeah.
And so it bypasses the optic nerve
Well, so
because
the
that's,
optic nerve originates in the retina.
oh,
And so the
because
optic,
that's what takes in light, sends it to the brain, and then the
yeah,
brain
yeah.
translates it into an
Well, it
image.
starts with the photoreceptors. They process the image, then they send the signal to the ganglion cell in the retina, which is the nerve body of the optic nerve, goes through the optic nerve chiasm and synapses in the lateral geniculate body.
Hmm.
And so it's a complex pathway. So what they're trying to do is just bypass all that because, you know, and again, if you map out when light comes in the eye and focuses, if you could map out the location of where that light is hitting that chip to the brain, you can bypass all that system because there's no way to reproduce. If the optic nerve dies, it's not going to come back alive. It doesn't come, you can't grow an optic nerve.
Hmm.
So although they're working on that, like in spinal cord injuries and stuff like that,
Yeah. Yeah. I've heard about
um,
that.
but
They're using stem cells, I think,
but
right?
with the bionic stuff, they're really basically bypassing that whole system right now. Anyway,
Do you think there's potential for that to at some point generate an actual image?
um, you never say anything's impossible.
True. Yeah.
Yeah,
Right. Yeah.
but I think we're light years away from it.
Yeah. Like, whoa, light years.
Well, I mean, yeah, that
Not
a long
not
way.
decades.
I would say I think we're probably a century.
Jeez.
Yeah.
Yeah. Well, I can only imagine. That's incredibly, incredibly complex. Hmm. I wonder if we'll get to a point where you'll just like some people will like how some people now, um their vision might be pretty great, but they'll still go get LASIK anyway just to make it a little bit better, or they want one eye to be nearsighted and one eye to be farsighted or something like that. I wonder if we'll get to a point where a patient will just come to, come to a doctor and say, "Hey, like just take my eye out, give me a bionic eye because it's just so much better. I'm going to be able to see,
Yeah.
I'm going to go hunting and I'm going to be able to spot a rabbit 200 yards away in high
Yeah.
grass."
Yeah. That technology would have to be really, really, really safe and good.
Oh, sure.
Yeah.
That's light
Yeah.
years. You'll have an app. You'll just connect it to an app. You could change your eye color.
Yeah.
You could
I don't know about that. Yeah.